Okay, so in this video we are going to derive an expression for the closed loop gain of an op-amp based on the assumption that the open loop gain A is finite. So A is finite. And what is A? A is the gain, the open loop gain of an operational amplifier. So if we have here an operational amplifier, here's the minus input, here's the plus input. This operation amplifier has an output voltage VO. This is plus, this is minus. This is taken with respect to ground. We ground the plus input, and we feed back from the output through a resistor into the negative minus input. So then we take another resistor here and we feed this by a voltage source. Let's call this voltage source VI. Let's call this resistor R1, this is R2, and there's a current I flowing here. Now this is at 0 volts. This input is the V plus, this is V minus. So now we know that the for a ideal operation amplifier, there is no current flowing into the negative input here. Both inputs have infinite input impedance, so the current I must flow through here. So there's the same current I flowing through here. So in this case, let's calculate. What we want is to find an expression for VO, the output voltage. And in order to do this, we need to find what is the current flowing into here, which is going to be the same current flowing into here, and we also need to calculate the voltage at this node here. Now, based on the assumption that the open gain is finite, then we know that V naught is equal to A times V plus minus V minus. That's what the operation amplifier does. It amplifies the difference between V plus and V minus, and this is called V naught, which is the output here, taken with respect to this ground. So we know that V plus is grounded at 0 volts here. So that means that V naught is equal to A times now 0 volts minus V minus, and that's equal to minus minus A times V minus. So V naught, V naught is minus A times V minus, but we want to calculate V minus. We want to calculate the voltage at this node here. So V minus is going to be equal, let's divide both sides by minus A, so that's simply equal to minus V naught over A. Now let's box this equation here because it's important. This is the voltage at the node V minus, so that's the voltage here. Okay, now that we know the voltage at this point, we can calculate the current flowing through resistor R1, because we know that the voltage at this point is simply VI. So that means, because the current is flowing this way, that means that VI minus the voltage at this node, which is V minus, so that's plus V naught over A. This divided by R1 is the current I. So we have just calculated the current I flowing here, which is also the current flowing here, and that's equal to VI plus V naught over A divided by R1. So now that we know the current flowing here, and we know that no current flows into here because this has infinite input impedance, so all the current must flow through the resistor R2. So that means now that we know the voltage at this node, we know the current through R2, and we want to calculate the voltage V naught. So we can write that V naught is equal to, the voltage V naught at this point is equal to this voltage minus the current I times R2, which is the voltage drop across R2. So V naught is equal to V minus here, which is minus V naught over A, minus the current I times R2, so that's minus R2 times the current I. Now the current I we have just calculated, so it's this expression here, so that's R2 times Vi plus V naught over A divided by R1. Now I'll divide by R1 here outside here, it's the same thing. So this is the expression. So again, V naught here, the voltage at this node, is equal to the voltage at this node minus the drop across R2, and the drop across R2 is I, the current I, times R2. So V naught is equal to minus V naught over A minus I, which is equal to V plus V naught over A over R1 times R2. So again, we have a new equation that we want to solve for V naught now. So we want to find V naught in terms of Vi and the gain, the open loop gain A. So let's simplify this equation now. So we have that V naught is equal to minus V naught over A minus R2 over R1 times Vi minus R2 over R1 times V naught over A. And now let's collect the V naught terms on the left hand side. So V naught, I'll just go step by step. Okay, so it's easier for you to understand it. So I'll just not neglect any steps. So V naught plus V naught over A plus R2 over R1 V naught over A, this is R2, is equal to minus R2 over R1 times the voltage, input voltage Vi. So now let's factorize V naught outside. So V naught times 1 plus 1 over A plus R2 over R1 times 1 over A is equal to minus R2 over R1 times Vi. Let's change colors. And so finally V naught is equal to minus R2 over R1 times Vi divided by 1 plus 1 over A plus R2 over A R1. So this is the final result that we get, that V naught, the output voltage V naught, is equal to minus R2 over R1 times the input voltage Vi divided by 1 plus 1 over A plus R2 times R2 divided by A R1. Now, so this is the gain, consider this is the output voltage considering the fact that A is finite. Now we want to show you that, I want to show you that as A goes to infinity, let's see what happens as A goes to infinity. A goes to infinity is equivalent to an ideal operational amplifier. So suppose that A goes to infinity. If A goes to infinity, then this term goes to 0 and this term goes to 0. So this is equal to, so the limit as A goes to infinity of V naught is equal to minus R2 over R1 times Vi, and these two go to 0, so we're left with 1 on the denominator. So that's just this here, so this is equal to minus R2 over R1 times Vi, and this is exactly what we get when we assume that the other operation amplifier is ideal. And in that case, when we assume that, we simply say that the voltage at V minus is exactly equal to the voltage at the positive input. So what's the closed loop gain then? The closed loop gain for an operation amplifier is simply equal to VO over Vi, and that's called the gain. Gain G is equivalent. This symbol here means equivalent. It's equivalent to VO over Vi simply, which is equal to this expression here divided by Vi. So this is equivalent to minus R2 divided by R1. And this is the closed loop gain of the operational amplifier. And that's it for now. So thank you very much for watching.